That was off. Is it? No? All right. Hello. Hello, everyone. Hello, everyone. Uh, Hello, everyone on YouTube as well. My name is Sergey. I'm representing 2600 in Malmö. Today, we will have a workshop on antivirus evasion and basic techniques. Okay. All right. Higher. Yes. Thank you. So, Victor will give us a presentation on the topic. As Michael said, we will have a pizza break at 6-ish, and then we will continue with the topic, and we'll see how that will goes. Victor?
Yeah, so today, as you guys already guessed or kind of just read, we will talk about malware development. It's not, we won't get deep into the subjects, right? So it's an introduction to malware development and AV bypass. Because this is an introduction, we won't focus on EDR and post blue team stuff like AI that analyzes behavior or anything like that. We are focusing on AV, more specifically Windows Defender, right? We will throughout. It's not a course. That's another thing I need to. This is not a course. I'm not gonna get into C sharp. Who here knows how to develop in C sharp? Because I don't. And this is in C sharp. So we will have to, try our best to understand this because I'm learning C sharp as I go. I'm kind of I like to develop stuff, but I'm not really a developer. So that's just one thing to know. And as an introduction to this, first of all, huge disclaimer here: we do not support any use of malware development or hacking for illegal purposes. Just so you guys know, you will all have a copy of the code, and this code, just so you know, will work with Windows Defender nowadays, but only normal Windows Defender. If you attempt to use it in the wild against any company that has any kind of EDR, it will be detected. Don't use it. You are going to jail if you do it. That's just so you know, right? Another disclaimer, this is the just so you guys know, this is the agenda of what we're going to talk. All the code of the malware is already here. We will talk about this is bit by bit. I will share with you. Do you guys have the Telegram channel? Are you in the Telegram channel from the 2600? Because I will share the PDF that also has, because otherwise, you'll be typing the code and it's gonna take a while if you want to type. So it's better to just have the PDF, and when we go to the parts that are relevant, you just copy and paste in your Visual Studio, right? So I will share in the Telegram channel in a minute. And yeah, so the other disclaimer that I wanted to say is nothing that we will talk here is original. I didn't create any technique that we will explore here. Everything you see here, you can see online. I don't claim to be the author of any of the techniques or anything like that, just so you guys know. Right? Yeah. So let's. Did you guys download the draft I sent in the Telegram channel? Do you have the Telegram channel? That's why you didn't download it. Enter in the Telegram channel. God damn it! I'm kidding. Uh, do yeah, he can send me the link. But anyways, let me see how can I share this with you folks then. Right. Oh, all right, I already have it. So Telegram, it's there. All right. Mm. let's open the draft then, and then you guys can see it here. In the meanwhile, you guys go into the Telegram chat and download this, because everything we will do will be with the basis. Like, we won't develop this part. This part is, it's this kind of the skeleton of the thing, whatever the thing is. Oh, com sucks. God damn it. This is the result of my experiences. Well, so yeah, I think I'm gonna have to make it bigger, right? What is fonts? Can you guys see fonts somewhere? Oh, here. Now, can you see it clearly? All right then. So for this implant, we will use some Windows API calls, and for that we have to import the kernel32 DLL, and we have to also create some definitions. So some of the functions from the Windows API use some structures of memory of data that we need to use to call those functions, right? So that's basically we are basically here defining the structures. So this is our startup info structure. This is the data you need. As I said, I'm not gonna get into explaining each bit of the code, because you will have the code. You can research it afterwards, and we don't have time to do that, right? But in any case, I will show where you can get that information, right? So if you go, for instance, all of these, some of these I will have to explain during the presentation. But anyways, so like for instance, if you go and see, let's say, virtual alloc exoma, right? If you just take it, open the browser and type it there, and go into the Microsoft thingy, and you see this is the definition of the function, right? But this is for the for C++, and we are developing in C#. So these data types, we don't have it in C#. So we have to create the structure to represent them. And like more importantly, you can see the last the allocation type and the file protect parameters. They are defined here, so you can see mem commit is this number, and these constants are basically this number. So mem reserve, mem reset, and if you look there, we have these definitions here. So we have it's here somewhere here. So we have mem commit, right? Page execute, read, write. So these are only for when we are developing the code. We will need these definitions and we will use it. That's pretty much it. Every function from the Windows API that we will use is already here. So load library to load the DLL, get proc address to get the address of a module in the DLL. In this case, a function inside the DLL. So it returns the address of that function inside the DLL, and so on and so forth. You can do your own analysis after the presentation. Did you all download the right? So let's start. So I will start talking a little bit about MSI, right? So and we will then implement the MSI bypass function, and I will explain a little bit about MSI. I won't open it in the debugger and show you the assembly and go into, because it's, as I said, it's not a deep course. This is not a course. It's just a workshop, and it's good for you folks to understand the workflow, right? And then after that, we will spawn a process, right? And this process needs to be suspended. So we will start the process, but the process won't do anything in the beginning because it will be stopped. And then within that process, we will allocate some memory, inject our payload into that memory, So we have to change the protections of that memory in the process, right? And then we inject our payload into that process, change the protection of the process back to where it should be, what it should be, and then we resume the process, right? And when we resume the process, it will execute our payload and in this child process. So even if our malware itself gets killed, the child process most likely will be alive if, depending on the EDR, if you're considering the EDR. The AV won't detect it, but an EDR would, right? And in order to establish how this payload will be executed, we will basically use the APC query in the user mode. This is a Windows API function that basically, as you can see, this is from the Microsoft definition itself. So when you assign when you queue a piece of code, something to an APC queue in a thread, when that thread, next time that thread gets executed, it will be interrupted and your code will be executed first. So that's why we will use it, because then we will assign a new thread to the process and inject our payload in that thread. When the thread is executed, we get our shell, right? For the reverse shell, I'm not saying here, but we use Covenant, which is a C2, and it uses C# as a work framework, right, for everything basically. And so just like Covenant and whatever. If you guys don't like it, you can always use Metasploit as well. It will work anyways, right? Yeah. So let's get into it. So the MSI, every time when you're executing a PowerShell or a .NET process, the MSI will be injected into that process, right? The DLL, MSI.dll, will be injected into that process. And you load anything to memory, or from the disk or something like that, the MSI will then be triggered, and it will scan for the buffer that you are loading, right? And it will look in that buffer if there is anything malicious. And if there is anything malicious, it will then return saying that there is something malicious there, and the AV will cut off your process or do something with it, right? That's basically how it works. Kind of how it works, if I even can say it. Anyways, um, so our goal here is to force the MSI function that scans your buffer to always say that your buffer is okay, right? That's our goal, because then every time it tries to read your buffers, your shellcode or anything, it won't be able to like, it might even know that's vulnerable, but it won't be able to inform that's vulnerable, that's malicious, right? So that's how we will bypass the MSI, right? And to make matters easy, so that we don't have to type everything from scratch, I inserted some snippets here, and we will use those snippets and talk about each line of the snippet, right? But so that we don't have to actually type everything, right? Oh, sorry for that. Um, so sorry for that, folks. It won't happen. Right. So this is the code for the MSI bypass, right? How does it work? This is not developed by me. As you can see, this is the technique was first published by Hastemaus, which is like a really like a cool guy that knows like pretty much everything you can think about. And like you can download the tool to bypass MSI yourself. It's in his GitHub, and he has a blog post that explains step by step with debugging and everything, so you better understand this if you want to get in depth, right? So if you really want to understand it. So what we're doing here is basically this is a base 64 for the string MSI DLL. If we just do something like this, you can see it's a base 64, right? And so this string will basically hold the base 64 of the string MSI.dll. That's nothing really important. And and here, no, it will actually decode on the fly and then assign it here. The reason for that is that when we compile this, we don't want the proper string to be in the binary, right? Because if the string msi.dll is in the binary itself, when the binary touches the disk, it will be flagged, right? So we need to avoid strings, malicious strings in the disk. So that's why this will be in the disk. This will be in the binary when you compile, right? And this not msi.dll. So here we take this, decode it, and save it into DLL1. And then here we load that DLL into this pointer, right? So this will point to the MSI DLL. Hey, folks. Sit anywhere. Yeah. Right, and once we load the MSI DLL, then we will look for this function inside the DLL, which is MSI scan buffer. Right, this is the function that will then scan the buffers and return if there's anything bad or anything good. There's one thing important about this function. Just so you guys, anyways, to show you guys that it's really that. This is the function, right? And so this will just have the name of the function encoded. Then we will decode it and save it here, right? And then here we will go and get in the library the address of that function. So this is the address for that function, right? Which is MSI scan buffer, right? So far, nothing. It's pretty straightforward, right? But then there is one thing. The scan buffer. There is a part of the scan buffer function that it validates the parameters it receives, and if there's any issue with the parameters, it will then branch out to another to a kind of it's like an if else, it will branch out, and in that branch it will then just change return value to an error. So it's saying I couldn't process this and return, right? And because of that, if there is an error in the parameters, the MSI will never be able to scan the buffer because it will always branch out to that part and skip the verification, right? And it's supposed to never happen because it's the Windows itself using the MSI, so the parameters should always be okay. But anyways, it's there, and the way to bypass it then is to force the MSI there's several ways, just so you guys know, but the way we will do it here now is just force the MSI scan buffer to always go to the error part. So it never scans. It will return an error saying I couldn't verify it, but it won't say it's vulnerable. And you have to remember, AVs can't be intrusive. When you're using your machine, you can't, every time you open something, MSI can't verify it and it just closes. Then it's intrusive. You won't be able to use your own computer. So if it can't tell if it's vulnerable, if it's malicious or not, it's just not malicious. So that's the way we will do it. And so here, this function, to do it, so we loaded the address of the function we want to modify, right? And now what we want to do is to write bytes to that function. We want to modify the function in memory, right? Because the MSI DLL in disk will still be the same. And the problem with MSI DLL, that's the fundamental problem with it, is that it's injected in the process that you are using. And because of that, you hold, rights over the process. You can modify your own process. When the DLL is injected in that process, then now you can modify the DLL because it's in your own process, right? It's not something that's in the Windows part and you're forbidden to access because it's in user mode and it's in your process. It's not even in another process. So what we will do is we will apply a patch to the MSI scan buffer to force it to always return an error, right? To do that, we will change in that address, which is the address of the function, right? We will change the permission so we can write to it. So I think it's a bit, I don't know if yeah, you can see it. So we will use the virtual protect function that we will pass the address, we will pass the length of the memory, how much memory we want to change the permission for, right? Anyways. and then we will say what kind of permission we want to apply to it, right? And we will save the old permission that was already there, right? So what we want is like it by default it's already execute and read. What we want is write because we want to modify it, right? So we are applying this permission that we defined in the draft. There is a define there. It's a 040 if I 0x40. It's a hexadecimal. Anyways, it's there. And after we change the permission, we then copy the patch that we just get here. I will still show the patch for you folks. So we copy the patch to this address, to the beginning of this address, and this amount of bytes, right? The length of the patch, right? After that, we just restore. We use the older permission that we got here, right? When we changed it, we saved the old permission. We just reapply it to restore it to the normal one, and that's pretty much it. When MSI is called, it will always actually execute our patch instead of what he wants to it wants to execute, right? And what is our patch? This is our patch. It's basically, but anyways, what this patch is basically there is an constant, which is basically, if I remember correctly, it's 88 70 57 0007. You know, it's this basically a number, but there is also a instruction here. So these are opcodes, right, in assembly. And basically what this does is it basically does move AX, and then the constant value, which is the value that says there was an error reading the parameters, right? And after that, it just do a ret to return. So it will yeah. I guess if I oh no problem. If if I remember how it's done. Oh, folks, I have no idea how to make it bigger, but I can use it under the terminal. Non terminal. Yeah, that's right. You open a terminal, you have to know your GPG key. That's security by design. And then you have a really small password just to stupid as fuck. Stupid as fuck. Yeah, that's true. Anyways, now we have the. So basically, what's gonna do? It's move AAX, which is a register. I don't know if you folks know a bit about assembly, but it's a register, and this register is in 62, 64 bits. It's used as a return. So every time you write a function, the return value of that function in assembly will be in this register, either in this or in this, right? This is where it like this is the 64 form of this register, right? And so it basically is saying like when you do a return 0 in your hello world, so you do int main and then return 0, right? When you do return 0, it just does like this and then rat, right? So just so you know. And basically in this case, just reversing, it will then put the constant here that I don't remember. It will just add the constant here and then return. You can see what is the constant if you just do like this and go to Firefox. Oh, better Firefox. And do assembly opcodes. Oh, opcodes to assembly. Right? And we can. Oh, not this one. This one. So you can always just come here, place the opcodes, 64-bit, and then you can see it does this, right? But this is actually wrong. This is a move. It's not showing the right, but this is the value supposedly that should be moved there. But you can see the opcodes here, right? Just so if you're in any doubt, basically. And once it moves the opcode, so this will basically verify if this architecture of your operating system is 64-bit, then it will return this uh, patch here. And if it's 32 bits, then it will return this patch here, which is the the opcodes for 32 bits architecture, right? And this is how it verifies if it's 64 bits. Just verify if the size of the pointer is 8, because 8 is equivalent to 64 bits, right? That's pretty much it. So this is the way the patch is applied. So what we do now, we just come here, take the code. You guys, I have to share the PDF, right? No, no problem. Sorry for that. Completely forgot. Not gonna batch that one. If you folks want to just download it, go for it. Anyways, so now we just come here, take our MSI. Ooh, man, this patch, copy it. I'm getting all confused because I don't really use this keyboard. I use a different one. Sorry for that, folks. Anyways, so here we just come and do static bool MSI bypass and place it, right? And as you can see, I think this font is a bit bigger, a bit too big, right? Uh, I think we can do it, make it a little smaller. God damn it. A little bit better. Anyway, so this is the patch, right? And as you can see, we don't have the get patch here. So we will just come here and take our get patch there. And you folks do the same with your PDF. Copy, paste, and when we will get to the juicy parts when we actually there is a part that's not in the agenda here, not even here. In the agenda here, there is a part that's not in this agenda, which is in the end we will attempt to include an automation for persistency in the malware. So once the malware infects, it will first create a persistence, then return a shell, and every time you reboot, you get a new shell, right? Yeah. So we did it, right? This is what we needed to do. Now what we will do is spawn the process, as I said. To spawn the process, we just have to pass what is the executable we want to start. It can be anything like Notepad or whatever you want. I would suggest avoid using, like you can't use Notepad to spawn a PowerShell or something like that, because that will be really, really not very good. Not for the AV, though. The AV will probably not notice. The ADR will, and the blue team will, but the AV won't even care, to be honest. But yeah, so we will create this process, and if you folks have any questions and why we are doing this way, because that's basically the purpose of the purpose here, right? The purpose is to define. It's not just copy paste, but understand why. And as you guys yourselves said, you don't know much about C sharp, so we don't pay too much attention to the code, but rather to why we are doing this way, because then you can do it with whatever language you want, C++ or whatever you want, right? That's all that matters here, the most important part. Uh,
Just hold it like that.
All right, so I'm interested in I mean, AMSI, anti-malware scanning interface, it's mainly used to scan for scripting languages,
Yeah.
and
And
it's commonly loaded within like PowerShell and stuff like that. It's not generally loaded into arbitrary binaries.
.NET binaries. In .NET binaries, it's loaded, not in PowerShell, or not in, normal, because the .NET uses CLR,
Yeah.
and because it has access to the automation and all the libraries that PowerShell uses,
All
it
right.
will load the MSI.
I only thought it was like when you use the .NET library within PowerShell.
No, wait, what you can use the PowerShell library within .NET. That's what you can
And the
like
other way
Sharp
around.
Shell. Sharp Shell is PowerShell only in .NET. So there's no PowerShell, but still it's PowerShell, right? So because of that, when you load the PowerShell libraries, it will then inject the MSI, and we can see it when you execute. Like we will test, we will open PowerShell, and then we'll execute a .NET that will bypass the PowerShell, and then we'll see the PowerShell is bypassed, or it will bypass MSI, and then we'll see MSI is bypassed. So
All right.
just right. So this is basically how we will start the process. These parameters here, like it's too much things, but what you need to understand here is what is the path to the executable you want to start, and what is the flag of the status of the process you want to start. And we want to start the process suspended. That's why you see there broken, but it's suspended, right? So we just copy that, go there, and we create a new. God damn it, man! This go there, and you can just do something like static um, process information, and then create process executable path. Place it here, and that's pretty much what we need to do here. And then we need to define the executable path, right? So, uh, oh, we don't have a main function here, right? Oh yeah, this is our DLL. So I will create a static public static void execute. And here we will define then string executable path, and then we replace our path. Because this is a malicious code, I will use, don't use it, but I will use the Windows and Notepad. Right? Don't use it, but you can use whatever. Like there's tons of executables that actually can spawn something or execute some weird stuff. Not Notepad, but I will use Notepad because if you guys are taking this to use somewhere, anyways, we go there, and here we can just do process information pi, and then create process and pass the executable path. Right? This is step by step according to what we need to do. Once we create the process, what's the next step? So this is important. As I said, we want to avoid at all costs anything that will be in the executable when we compile it, so that if it ever touches the disk, it might never touch. Like, to be honest, the way we will do here, it's to never touch the disk anyways. But if it ever touches the disk, we don't want it to have any hard-coded, or even if it doesn't touch the disk, if there's any dynamic analysis, we don't want any hard-coded weird stuff or malicious stuff in memory, right? Right when the process starts. After that, we can play a little bit, but in the beginning, we don't want that, right? So what we will do is we will store our payload in the C2, and we will force our malware to download the payload. Once it starts, then it will create the process, bypass MSI, create the process, suspend it, download the payload, and then inject the payload into the C2. So the payload is not even if you save it into the disk, there's nothing malicious. This code is not malicious by itself, right? The malicious part is in your C2 or whatever you want to host it. Or you could even host it if you modify it. You could even, like, if you're in a network, you can host it in your machine and share with via SMB, and your malware could fetch it via SMB. That's a way to do it as well. You just have to modify the code. In our case, because we're running it locally, I'm not using SSL or TLS. If you want to use it, you just uncomment this line here, right? It will set the user agent, and it will also set to use TLS and SSL. And you change these lines, and when you call the function, you have to pass an HTTPS endpoint, right? So we take this, copy, go there, and we create yet another function, which is static. This will return the buffer, so it's a byte. Download payload, right? It receives a string URL, and that's what it does, right? And this, when we are executing it, if we compile it with the debug flag, it will print the size of the payload, just so if there is something sketchy, we can see if it's actually downloading the payload or not, right? Right. So, and now here we go back there, modify it, string URL, and here we place the HTTP. We don't know yet. Oh God. HTTP. We don't know yet the IP, but it's just so that we don't keep receiving an error. And then what will be the shellcode, right? We'll place here. We'll place shellcode encrypted dot bin, right? When you host your shellcode, don't host it with the name shellcode. Yeah, that's the gist of it. Like, yeah, these tips, of course, are not even tips, but they're more for the blue team and for the EDR than the AV itself. Because as you will see here, like we're creating, using Notepad, we will host with the name shellcode. Nothing matters. It will work anyways. But when you have a endpoint protector, everything changes. This won't work, right? Then you have hooks in the API calls that you have to unhook, and anyways. So what's the next step? Next step is to decrypt the payload. So the payload we are downloading, we will upload the payload to our C2 that will be encrypted. So even in memory, the payload will be encrypted, and we will decrypt when we want to use it, inject into memory already decrypted, and that's it. We don't want to keep it decrypted there for too long, right? So we will create the function to decrypt the payload. So I suggest you guys actually do it, because in the end, I will, this VM that I'm using to code this, we will execute like there's nothing mine in this VM other than if you want to get infected, you can download anything because there's only malicious stuff. But anyways, we will then expose this machine, and we can take your malware and run here and see if it works, right? Don't worry, you won't get infected by my things, even though I was already. So now we come here and same thing, static byte decrypt payload. It receives a byte array, which is the array we downloaded here, right? Encrypted. So this function, you can see the buff is a byte array, and it will hold the payload, right? So we need to decrypt a byte array, right? It's the C array, right? Not the C# array. Because C# array it's another thing, anyways. And then we just put payload enc, or enc payload, I guess. Enc payload. and we create the function, and here we just place it, right? And for the encryption and decryption, you can use several stuff, Shore, whatever you want. The AS I'm using more because, well, the way I started using it is because I had an what's the name? A colleague in work that used to use this kind of thing, and I just liked it. So I'm just using it. There's no particular reason. A Shore would do just fine as well. It's so yeah. On the fly, it's just as hard because the EDR won't be able to decrypt it. And we are using this password for decryption, right? So I will show. We will generate the payload encrypted, and so that you know how to encrypt it. But if you type AES encryption in C#, you'll see basically this code. Oh my! As I said, nothing here is really original. And then we just come here and do byte enc payload download payload. I did it now. Download payload URL, and then we do byte payload equals decrypt payload and enc payload. Right. Now we have the payload. We will download it encrypted and then decrypt it, basically. And right after we decrypt it, we will then move on to allocate memory into the process that we want to inject our payload to, right? And we created the process. If you remember, the PY here is the handle for that process. When we created there, you can see here, PY, right? When we created that process. So we will allocate to that process, in the beginning of the process, we will allocate this amount of bytes, which is the size of the payload after decrypting it. The commit is because we want to write it, and this is because we are allocating, right? This is the permission we want to our memory to have, right? We want to read and write into this memory, right? And so we basically just remember, folks, I'm not a malware professional or of any sort, so he probably has way more knowledge than I do. Go for it. What was it?
All right. So when it comes to the virtual alloc function, why are you using virtual alloc x NUMA instead of the usual virtual alloc?
Well, you can use the virtual alloc x NUMA, but in this case, it's because we are allocating into a process and not into our own space memory now. So our malware will have a space memory. We are starting another process and allocating memory there. That's why we have to use a different API. In this case, it's virtual alloc x NUMA. That's basically the reason. You could use also virtual alloc, but it will only work in the process you're running, in the malware itself, right? And we don't want to allocate memory into the malware memory, but in the child process that's not running it still.
Yeah. Thanks.
Yeah. So static, but it's good that you asked because I completely forgot to explain. So we don't have to create a function for that. We just come here and allocate the memory there. So this is a pointer for that memory now, right? And after we allocate the memory, what we want to do, let me remove this here, right? So after we allocate the memory, right? What we want to do is to write our payload into that memory, right? Because we allocated, now we want to write it. This is the part that is the actual injection. So we allocated memory into the child process, and now we are injecting the payload into that memory into the child process. So this is the part that's actually the injection part, right? So we allocated. Oh. So as I said, like if you are doing it in C# in C++, you would use the same functions. Even the calls would be the same because this is actually like this is a Windows API to be used with C++, right? So just that's why don't pay too much attention to the C# part. It doesn't really matter too much. I just recently started playing with C# and I decided, you know what, let's do it in C#, whatever. Yeah, so here we are allocating to the process. This is the handle of the process, which is the ID, and then this is the address we want to allocate to, right? This is what we want to allocate. This is the size of bytes that we want to allocate, how many bytes, and this is how many bytes were actually written, right? So if 0 bytes were written, then an error happened, right? And after we write to it, we open the process. Oh, yeah, we open the process. So we will open the main thread of the process, which is where we want to assign the APC query in the future, right? Which is so this will be the handle to the main thread of the process. So the thread process set context, and then we will get the process handle thread ID, right? How all of this works? That's a very good question. I thank you for not asking. You guys are awesome. And so we open the thread, and now we will change the permissions to it, right? We will change the permissions because now is when we will assign the. You can see here below. We will assign the query to the thread, right? So we will change the access to it. We'll actually return the access to the way it should be in the beginning. When we allocated it, we allocated as read, write, and execute, right? It needs to be read execute, if you remember. So here we are just setting to that memory in that process. We are setting the permission to that memory to only read and execute, right? So that we can actually use it. I don't know this Visual Codes of Visual Studio. It likes one function, and then if you don't do anything, it will just suggest the same function over and over. It's stupid. Oh man, VM way better. Yeah. So after we restored or we set the access memory to the proper permissions, now we can set the query, right? So we get there. Here. Right, let me just check how many. So, anyways, I won't be able to compile this. In the end, I'll have to create a project and then copy paste to compile it because this one it doesn't have any stuff for the Visual Studio to know how to compile it. Anyways, so we do it, and so when we assign the APC query in the user mode, as I said, and as it says here, next time that thread is scheduled to run, there will be an interrupt, and our payload will be executed first, right? It will take the place. So here we're setting it, so our address there to that thread, right? We're setting there to the initial point there, and here we resume the thread. So when the thread starts, it will execute our payload, right? Yeah, it's called process hollowing, right? So you create a process that will sacrifice it because the DLL the malware itself will do everything and then finishes, but the child process will be created, and then we will inject our payload there, resume the thread. It will then execute, download our stuff. Will execute basically, download our agent, and then start, because our agent will be the covenant one, and the covenant is basically another downloader because it will download from the C2 again. Anyways, and then that process will basically become the malicious one, right? So yeah, if you want to stop, let me just place this there. We can go eat and then come back. And after this, what we will do is compile this, set up a C2, and test on like by hand how it works, and then we will get into delivery, right? Because this is not writing the malware is not all. You have to come up with ways to deliver it without being detected and without touching the disk, stuff like that. For the persistence, it's more complicated because most of the persistent techniques you will have to save something into the disk. So this is more complicated. I would suggest if you have to save something to disk, try saving, JS icon file that contains malicious stuff, or a DLL, even because the DLL is not executable. If you run process hacker or so many process managers, they will show you all the process there and executables that are not native from Windows, but it won't show all the DLLs that are not native. So you can save a DLL, especially if you save it into download folders. Users download stuff. It's less like if you save in C / in the root, basically of the operating system, it will be flagged like right away, or in the app application data. Don't save stuff there because normally there's no executable there. If you save an executable there or a DLL or whatever, it will be flagged. You have to save it where, if you download Visual Studio now, what do you think is going to happen? You download it into downloads folder. Downloads folder usually has lots of executables there, So that's pretty much. Let's see then, and then when we get back, we will talk about delivery, and then we set up the C2 and execute it, and then we go for the persistence. And for the persistence, I will have to create a new user because this user is already infected. So I'll create a new user because this is in user mode, and it's low integrity kind of access, right? We're not running it into admin level of access, right? That's pretty much. You want to eat now? Let's go. That's cool for me. That's 30 minutes. All right. So, folks, ah, ah, ah. So, while I had this pause, I took the liberty to just move our code that was, in just one file into a project, right? Just nothing special. I just came here. I just came here, created a new project, right? So if you want to do it, anyways, you just go select C# Windows Library, and then go into DLL here and create a new project. Place whatever name you want, and .NET, this version of .NET, create. That's about it, and then copy and paste the whole code there, right? Just so we don't have to go into the hassle of when compiling it. We can just come here and use the beauty of Windows. Click, point and click. Anyways, so after I moved the code here. We can see there's an issue with the MSI, and I created it as a Boolean function because it's gonna be the first thing that is executed by the malware, right? If MSI is not bypassed, I want the malware to stop and don't do anything else. Because if you're a red team operator, or I hope not, you're part of a threat actor or something like that, you don't want to continue and be detected, right? If the initial steps of your malware didn't work, you want it to just stop, and you do it in some other way, or deploy another malware or whatever, but you don't want to continue, right? So because of that, we have to change this function to make it works. And using my profound knowledge of C#, what I'm going to do is basically do try, let everything there. If there is anything wrong here, I'll catch and do a return false. Otherwise, return true. Right? Oh, right? That's it. That's my profound knowledge. That's my ace in the sleeve. And that's so now we can see if the error was removed. And we can only cross our fingers now, because this is the moment everything goes wrong, basically. Oh, actually not. Woo. So I saved it with this ugly name. So our bad thingy, right? This is our malware. And like, if you want to import this DLL in any way you want, you have to just remember that the namespace is implant, the class is stager, and to execute the malware, you have to call the method execute, right? So because of that, we can test it with PowerShell now. So we deployed C2 here, right? So we just come here. This is way too big. Yeah. So if you don't have Covenant in your machines, yeah, I know I'm stupid. I should have said that you should download Covenant. At least if you want to play it when you get home, right? Firefox. You just go to Covenant C2. Oh, anyways, Covenant C2, and here you just, if you look here, it says you have to download the submodules as well, right? So you just use this command here. Oh, god damn! Use this command here. Go somewhere. I'm gonna create a new one. Just and we just use that command if it wants to copy. Yeah. Yeah, awkward silence, I know. That's true. Anyways, once you do it, you enter covenant.net build. If you use Linux, you have to install .NET version 3.5 or 3.1 with whatever version of Linux you want, and that's your problem. And then sudo .NET run. Who here ever heard about Covenant before? Of course, of course, of course. Who else? Nobody. All right. So we can. I'm gonna show you a little bit. So you can see it will deploy to this address here, right? So I just go there and 27. It will say the certificate is not valid. You don't care about this. Is self-signed. And you create a user and create this, and that's it. This is Covenant, right? The good thing about Covenant is that you can create a server, right? That will where you can host your files. For your assessment, if you're doing an engagement and you need to download a file for some malicious thing for somewhere else, or you need to upload something, exfiltrate some data somewhere, you do it through the C2, right? So it's a way to facilitate your tasks. To do that, you just come here, create a listener. I'm gonna do as usual HTTP listener name. I'm gonna assign it to every IP I have in my machine to the port 80, and you can leave all the rest the same the way it is, and that's it. You have a listener running, and here you can then just, if you want, you can just come here, host, and you can host files. So if you just come, let's say something, anyways, this, right, and you save. I want to serve this file at this URL, right? Just as a test, if you do, and let me grab my IP here. Sorry. And you do mp.dll, you can see it will download, right? So it's being served there, right? In this case, we will serve our DLL here eventually, but now we're not gonna do any of it. What we will do is create our launcher, right? So you come here, you can either create a shellcode or a binary. Better? So you can create all these kinds of payloads or stagers, if you will, and for us, we can create either a binary or a shellcode. What I like, when you have a .NET binary, it uses the CLR as just like the virtual machine from Java, but for C#, right? It's an underlying interpreter for the C#. I forgot the name of the language. Anyways, so a process that does not use CLR won't be able to execute your shellcode if your shellcode is developed in C#, right? If you try to execute it, it won't work because you don't have the CLR. So one way to solve the problem is you can convert your shellcode into a normal unmanaged executable, or you can use .NET, right? .NET is a tool that will convert a binary into a shellcode that's already free of CLR, right? And then you can use that shellcode because then it will work regardless if you wrote it in C# or .NET anyways, right? So for this case, we create, you can save, like, it doesn't matter here, to be honest. I don't know why as well. I like the payload is developed in .NET 4. I expected it to not work in 3.5, but it works. So anyways, especially I just think I don't know enough to understand. And then you save your payload, your stager from the C2. I just froze a little bit. So here, what I'm going to do is move this stager, just so you guys know how it works. I'm going to move this stager to the VM, disable the AV, and execute, so you can see how the access work, right? So how do we do it? I think we already have access to it here. So if you go CX encoders, yeah, let me just disable the AV here real quick. Disable everything. And now if you run, if you remember the name, it was grunt.exe, right? If you just run it, we got an access here, right? So if you go into grunts here, this is your access, and you can just type here whatever you want. Who am I, right? It takes a while because I don't know if you guys are familiar with C2 command and control. Anyone? Yeah, so the way C2 works, like it's basically a server, and you, instead of having a reverse shell like you have with Metasploit, that machine actually communicates back to your machine. What happens is that you will have a web server and your or API or server, and when you infect the target, your malware will be, or your stager implant or whatever, will be communicating with your web server, and you will post in your web server what you want the malware to execute. It will then fetch the command, execute there, and then send a post request with the response of the command back to you. Because you want to be, you don't want to be suspicious. You don't want, type lots of commands and all of them are executed like this, because then you have too much information being sent to a suspicious target or suspicious endpoint, and it will just alert the SOC and everything. Because of that, you can modify the grant and put some timers here, like a delay of 5 minutes and a jitter of 5 seconds and a jitter of 10 seconds, so that it randomizes, and it will, so every time you type a command, it will take a little bit for it to execute, right? But anyways, just so you guys know. And out of curiosity, you have all of these already here, so you don't have to download Mimicat, download anything. It's all here. Rubels, everything here. Like I want to use Rubels, that's it. Task it, it will execute. Right? That's why C2 is pretty good. Yeah, it's pretty good. Yeah, so it's pretty powerful. Right. So our goal now is to do the same we did, but now with the AV enabled, right? So let's just go here and kill this process. Exit, and it's dead, right? Right. So how can we go about doing this, right? As you can see, so our malware will download the shellcode and inject it, right? So we generated the executable, but not the shellcode still, right? We have an executable there. We need to turn it into a shellcode. So you can go there. Let me first show you the .c#. Not this one. This one. You just download this and compile. You can use. It has all the commands here to compile. It's not really hard. It's pretty straightforward. If you don't want to use it, you can attempt to use the shellcode from here. From here, just a shellcode. To be honest, it should work with the shellcode. I find weird behavior that with this malware, it might work or might not work. Sometimes it works, sometimes it just doesn't. I just don't know why. Anyways, so usually what I do, I use the binary and generate the shellcode from the binary. But let's do it with this. Let's play with luck. So we save it there, and now what we do, we go. As I said, you can look how to encrypt in C# online using AS algorithm. What we will do is just go there, and we have our file there, right, which is one of these, uh, this one, right? So we will encrypt it using AS, right? And we pass the name of the file, which is grunt.bin. It will generate another file called grunt.bin enc, right? Uh, just because, let me see how it downloads there now. Oh, now, now that we know where the C2 is running and in what port it's running, we can, because you remember we didn't place the URL, right? I just wrote IP there, right, in there. So we have to change now, and so go there. Where is it? Here, right? So now we grab the C2 IP address for the listener. Go back there. Here. Replace it here, and I will replace the name here as well, because otherwise I just have to keep. No, you know what? It doesn't matter. Keep it like this, and then we go back there, go into the listener, host, create a file that we want to host, and we will host the file we just encrypted, right? Which is this one, right? And the file we want to name it as shellcode enc.bin, right? As I said, never use these names, this kind of thing. Never gets. It's better if your malware actually downloads an icon and extract the shellcode from the icon, or if you have an image and you, as I was talking to him, you can just replace, like, you know that every pixel uses 4 bytes, and you can modify one of the bytes for, so each byte of each pixel in the image actually represents a character from your shellcode. So you can extract then and then build your shellcode in memory. Do something like that. Don't just expose a file with the name shellcode, especially with the extension bin, which is like, come on, no. But anyways, so now we hosted the file, and let's save here. Let's save here and compile it again. And just to see if it works, right? I'm just gonna grab where the URL is. It's here. And just to see if it works, remember the AV is disabled. We do system error reflection dot assembly, right? And then load file. Place the file there, right? It loaded the file, and now we can do implant dot stager, right? And then execute. And you can see the name of the size of the payload. That means it downloaded the payload, and you know the size. This is the size, because if you go there, you can see we got in the session there. This is the size of the payload, right? And it's just printing it there. It shouldn't print anything. You don't avoid printing anything to the output or anything anywhere. To be honest, it's doing it because we compiled using the debug here. So if you change to release, it won't print when you execute, right? But you can already see the malware is working, right? But more, the malware is already working even with the AV enabled. Enable here. This is the only thing I will not enable in the AV, because if it gets caught, I don't want it sending samples to Microsoft to create signatures and behavior and stuff, So this will keep disabled. Forgive me for that. And we do it again, and we go there, and we have a session. And if we go there, this is 1A in the end, right? And if you go there and you do, who am I? can see it's working already. So it's already bypassed, but it's not the best approach, right? We are still saving the malware into the disk, right? That's not a good approach. Man, my glass is already like it will break at any moment. I just thought, look at this crazy man. Anyways, so uh, what we need to do now is avoid using the disk, right? So we can create a PowerShell script that downloads the malware into memory and then imports the as assembly bytes and invoke our method. You can also save the malware into. You can also create another executable and use a lobbing. You can use install utils. Install utils. I know. Do you guys know what install utils is? Of course you know. God damn it, you guys know what install utils is. Well, it's a tool that you can install or and uninstall stuff. So if you do install utils and you pass an executable, inside that executable there should be a function called install, and it will just call that function. If you pass install utils slash u and then the executable, there should be a function inside there called uninstall, and that function will then be called. And it's basically when you want to uninstall something from your computer or install something, this is the kind of an auxiliary executable from Microsoft to help you create your installer and whatever. But because it's signed by Microsoft, if you create an executable that has nothing in it, the only thing it does is download. It will download the DLL into memory, and then it will inject the bytes of the DLL, or it will and then it will take that DLL, convert into an assembly object, and then look for the method, the execute method, and then invoke it, right? If you do it, then when you have it in disk, it's not malicious whatsoever, and it's a normal executable. You can have in your home folder. It's completely normal. If you want to install anything, you will have an installer there. Like if you download anything from the internet, it's an installer, any program, right? But when it calls, it will then download the DLL inject, and it will work. And it will be bypassing lots of checks because it's signed by Microsoft. That's another way to do it. Today we will do it using a PowerShell script, and I'll tell you why. Because if we have time, I don't know if we have time, we will also create the automation so the malware will infect the target. Once the malware executes there, before injecting anything, it will inject a DLL, a custom DLL, into a COM class, and then every time you reboot your computer, that COM class will be executed. And the COM class we will inject is the one that verifies your keyboard language. So the only thing the target won't be able to do if you do it is that every time he tries to modify the keyboard language, it won't work anymore. But you will get remote, like it will take ages for the guy to notice that, oh, I can't change my language, But now you have a remote persistency, right? So if we get to that, if we have time to do it, right? So now what we can do, I have a script I should have added to the PDF. I didn't, and I'm not sorry for that. But I should. But anyways, the script we will be using, I'm gonna use the other terminal because Sergey there needs to, terminal. Right, so. Whoa, what happened? I'm already hacked. Arsenal right team misc payload. Right. And then the encoders. And the PowerShell we will use, it's actually, oh, I'm stupid. It's here. I'm very stupid. So this PowerShell will bypass MSI before calling this, just in case, because this will most likely be flagged. So it will bypass MSI in itself, and then it will call this, which is basically download our malicious DLL, right? And then download it as byte, and then read that byte as assembly. So you're loading it as an assembly, and then you get the type, which is an implant stager, get the method address, which is execute, and then you invoke that address. that method, right? And that will execute our malware. And we don't like then because of that we can serve this file in our C2 and then use PowerShell EX. The whoever uses PowerShell know the drill. Let's do it then. It's here. Oh no, it's actually here. So we go there, here, 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 here. But before we have to change the payload there. Man, I'm lost. I don't know. Ah, here. Funny enough, I'm developing this user interface to be more productive, and I get lost all the time. So I know it's working. But yeah, so once again, on terminal. Save this here, but we need to change what is the payload we want to download here, right? The IP and the payload. And remember, if this you're using HTTP, avoid using HTTP because then in the transport layer, if you're using the HTTPS, anything in the transport layer will have like you have firewalls like Palo Alto and everything that can see it through, but like not all companies have those firewalls, and even if they have, not all companies have the configurations enabled to actually inspect your TLS packages. So let's get the IP. Yeah, true. You have to. It's layers. Just like if you're part of the blue team, you have to rely on redundancy, right? You can see the similarity. Back 5 years, 10 years ago, you could write a very simple malware; it would work everywhere. And then they change. They create a signature, and you change something like just add a printf or something, and it would work again because the signature is different, right? And now you have all these problems to create your malware. So you have redundancy. You have to encrypt your shellcode, inject DLLs, and do all this redundancy to get to the same point, because the blue team applied redundancy there as well, right? So we have redundancy is the key. You can't rely on one threshold. What did I do here? Right. So I'm get here the IP. Just go here. Place there. Save it. God damn. Let's save here as deliver this.ps1.txt. Saving as txt because I don't want to serve it with the last extension as PowerShell. Right, so we go here, here, and we take our delivery. If I can find it here, right? So we save it in here. We just save it as deliver.txt. It can be whatever you want. Right. So now we are serving the PowerShell that will then download our DLL, that will then download our shellcode, and then get our reverse shell, our connection. It's not even a reverse shell. The connection, right, to the beacon to our C2, right? Or rather a grant. But we're not serving the DLL, right? So we need to now come here. We compile this. We can't while we have this. So we compile this. God damn, we take this here. And we copy this to Axe encoders. Right. So now we have our DLL there, and we serve it as well. Go, create, explore here, And if you remember, mp.dll, right? And you can put any name, but you have to change the PowerShell. And now we are serving already 3 files, but only this one we need, right, to execute this. So now the only command we actually need to execute in the Windows is something like ex wr, and then http dip. Very good. The IP that I need to remember. The IP, and then deliver.txt, right? Hopefully it will work. I always get a bit of that fear factor. Oh, there's something wrong here. Oh, there's something wrong in the PowerShell, which is a shame. We're gonna have to edit everything. God damn. Arsenal, right, MISC, payload, right, encoder. Deliver this, right? And what is mistake? Now is the moment everyone was fearing that would happen. I say everyone, but I mean me. Now, line 2 here. Oh, here. Oh, I think I have to open the braces somewhere. Yeah, exactly. And there's this 4 here as well. You know what? To fix this, what I'm going to do is this. I copy this. The lever here. This here. Yeah, you can see there. I didn't open the function there, right? Oh, it's already there. Oh man, I already had the file created. Right. So now it should work. We go there, hosted, deliver, delete, go, create, file. Now we want to deliver the other one, which is this one, and we just serve it as deliver.txt. Go back there, and we got, so it's working. So now we already have a working shell, right? So you can place you don't need to use PowerShell, to be honest. You can use Visual Basic, or you can use JS. There are some JS engine that you can use with a JS file. You can make Windows execute, and then you can get your shell executing. But the malware itself, it's already bypassing. There's the AV was enabled, right? Don't remember anymore. Imagine I'm saying everything bypassed and then it's disabled. Oh god! And then I read it doesn't run. Oh shit. Anyways, yeah. So you can see it's already bypassing. There's we can do whatever there. There's no detection whatsoever. No any let's just see. Let's use seat belts. Right, seat belt. I typed enter twice. That's why this is the one that matters. And then we have seatbelt working. And I don't know if you guys heard about seatbelt before, but seatbelt will just do an enumeration for you. You can use lots of parameters here. In this case, it's just to enumerate things for the user that's executing it. But you can run it to audit if there is any antivirus, what is the MSI engine that's running in behind. You can enumerate this kind of thing, because this is the first step. Once you get your initial compromise, is awareness, right? You want to know what's in that machine, so you know what you can do, you can't, because if you have something advanced, it doesn't matter if you're malware bypassed, because it will get you by behavior, right? You start doing stuff that normal pen testers or red teamers do, you will be detected by behavior. So yeah, you can see it's running. And that's pretty much the bypass, guys. Ta-da! If you want, I can show you or attempt to show the persistence via com injection. I don't know if you guys know about it because I won't be able to explain. Uh, no, I can explain like how to do it, how to do it. Like, this code is like all original mine. I wrote. This is not one of those that I got on the internet. I can explain it, but it will just take a bit of time. It's up to you, folks, because you have to. It will. So when you turn on your computer, lots of things happen, right? When you log in, and some of those things are tasks that are scheduled to happen every time you turn on your computer. Like your clock has to sync. Everything has have to work. And some of these things use a com class because com classes they usually point to DLLs or executables that will expose classes and functions and modules that several programs can use those functions and modules through the com class, right? But problem is when you have a com class is basically a register, right? And it will be either in the HKCR on the HKML, which is either in the root registers or in the local machine registers, right? But it can also be in the current user registers. And the thing is, if you have a register that has a com class and the com class is not pointing to any DLL, you can just place a DLL there, and every time that class is called, the DLL will be executed. But you can't just do it with any class. You have to do it to a class that's tasked to start. And if the class already have a DLL and you have permission to write there, then it's a basic DLL hijack, right? But what we want to do is you look for a class, a com class, that it is in the local machine registers. It is in the root registers, but it's not in the current user registers, right? Those are the ones that you want to inject because you won't break anything, and it's empty, so you can point to any path, right? And the thing is, the current user register takes priority over the rest. So even though the register might already exist in the root or in the local machine, so it applies to every user, for the current user, you can modify it and it will have priority. So if you inject it, it will always execute for that user. It bypasses, the other registers. So that's basically how it works. The C# will just look for a com that is in the local machine. It is in the root registers, but it's not in the current user, and then it will just place a DLL, download a DLL that we want to the disk, to a place that we want, and then set the path of the com, create an object. There's some stuff that you have to do first, but then you will point those objects to that DLL, and then every time you log in, the shell will be popped for you. And that's pretty much. We would use a com class that I know won't break the Windows itself, because you can replace something that I was in the office working these days, and when I was writing, because I deleted this thing that I wanted to bring to this presentation, and then I had to rewrite. And when I was writing, I forgot to select what class I wanted, and it replaced all of them. And all of a sudden, the mouse was like, and I couldn't control the mouse. And it's not that it was controlling the mouse; it's just that the bytes that it was reading for the mouse position was all over, so you couldn't. I was trying to move the mouse, and the mouse was like, it was really creepy. Like, man, I've been hacked or something. Yeah. So, anyways, it's pretty fun. Yeah, adventures playing with malware. But yeah, like, if you guys want to see it, I can do it. And to do it, sorry, I didn't listen. Yeah. Well, code signing is a problem, right? You either have a license from Microsoft to sign your code, or you have a partnership with them, or you just don't sign it. Yeah, like you can like man, lots of companies. If you look on internet, you will see like lots of keys to sign your code that was leaked, you know, and you can use one of them. Sometimes they generate a new one, but they don't revoke the other one, and then you can just use it. But it's not gonna be easy, you know. So it's better to just like, to be honest, if you download any free software, they're not signed, you know. Yeah, kind of like to be honest, like when you download something from Git, there's no signature there, and the AV won't say anything, you know. And that's you just your software just needs to be look innocent enough for the AV to just forget about it, and then when it executes, then it does everything in the memory, and then your battle is not against the AV, it's against the EDR that will look for the behavior, right? Yeah, 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 exactly. Yeah, so let me just. So we're gonna do it. We're gonna rush it, right? So I'm gonna open the class. Let me just try to remember what's the name. Codes. Test DLL. So this is the DLL we will inject there, right? Forget about this message you never saw. Uh, this is a C++ DLL. Why C++ DLL? Because we need, because it will be executed as a COM class, like the system itself. Yeah. No, this is a known problem with the NVIDIA graphics card. It has a memory leak, so after a while using it, your computer just reboots. So it's basically a malware. Right? Imagine you have a server that's processing something but needs computer power, and you have an NVIDIA there, and your server just reboots. Oh, damn. Now it's the shower of passwords. It is. It is. Shower of passwords, man. God damn. And not just that. The screen might be green. She's. That's good. Virtual box. Run the machine. Right. Keep it like this, just for the sake of it. Yeah, I have two users because the first one is impossible to log in now. It's nothing works. Oh damn, not fun. Look at the message, man. This happens because I had a message box here, when I was trying, like, attempting before, and then it's already infected. So every time I log in, the message box keeps popping, and yeah, bad. But yeah, so this program, all it does is, well, going back to why it's in C++, because as it will be when you execute a DLL that's in a managed language like C sharp, you have to pass to the executor that is executing the DLL what class of that DLL you want to call, right? And what function of that DLL and stuff like that. And in this case, we can't do that. There's no way for us to do that. So we have to use an unmanaged DLL, and we tell to that unmanaged DLL that every time it's being attached to a process, you want it to execute this. So every time someone loads this DLL, use the load library and pass the path to this DLL or run this DLL, it will execute this, right? Which is our PowerShell command. And this PowerShell command will basically download what? I don't remember, but we can always see. We just grab here. Oh, that's why I like Vim, because I could just decode it on Vim itself, right? All right, yeah. Get on terminal. Cool. And then base 64 minus D. All right, so so what this DLL will do is just execute exactly the command we told it we did it right now, right? So it will evaluate the shellcode or the PowerShell script we created, right? So it's already served there. We just have to change this IP and re-encode it. Yeah, yeah, but it is now it's a PS1, but it's a TXT in the end. You can see there. But yeah, never good to use PS1 as well. Although to be fair, most companies, they download from somewhere PowerShell commands to sync to execute stuff that the domain controller wants, or whatever maintenance stuff. Ah, yeah, yeah. From the one I'm serving. Yeah, I agree. But in any case, it's good to avoid using PS1 in the extensions. So we just copy this, go back there, and then there is this weird thing. I don't know what happened to PowerShell. Why PowerShell has so many good things, and to encode something to base 64, it's a hassle. What's the problem with them? We just come here, change the IP. Oh, I don't remember the IP. So I have to open the Firefox once again. Visitors, grab this. Go back there. Where is the here? PowerShell. God damn. Right, so we save this string here, and then we just have to remember how to encode it, which is true. And now we have to encode it. Just wait. Well, I'm not gonna. I think this is the one. This is the one. Yeah, man. No, but look at the size of this command to encode it. It's stupid, man. PowerShell should have a function to do that. It's stupid. Come on. Let's just see if it because sometimes the encoding is different, and it won't decode it properly, right? So we just base 64 minus D. You see, we have to use Unicode, and yeah, stupid. UTF-8. No, because the Linux uses a different ASCII table. Yeah, yeah, that's a proper answer. That's a proper answer. Yeah, fuck Windows, man. Yeah, this works. So use this one. What? Yeah, Windows, man. I don't know who. Yeah, but like if we decode here now, it will work anyways. Let's. I don't even remember how to decode it, to be honest, but we can attempt. We do get. I think it's get bytes from string. No, it's no, it's there. So stupid. No, from. No, it can't be from string because then it will return the byte code. Well, basically, this is the decimal for the ASCII table. But anyways, we will test it. If it works, it works. God damn it. Anyways, yeah. So it will just every time this DLL is called, it will just execute this, right? This is the first step. We need to have it working. So we compile it. Oh, beautiful! It compiled that. Oh, amazing, amazing. We just go there, and serve yet another file, and it's gonna be here, I guess here, and no, not here. It's gonna be here, and it's where is the yellow? 64 debug. Debug. Can you guys see DLL here? You know what? I'm not gonna waste time. CP 2x encoders. That's it. And now we go back here, which has more files. Not easier at all. And we save it as test DLL. Let's save it as something like something and create it. Right? So now we have our class exposed, and what we want is a script that will actually inject, verify the com, create an object there, download the DLL, save it somewhere else, and modify the object in the com register to point to that DLL. Right? So that's the mindset. And we have it magically here. Ta-da! This is a tool I've been creating. It doesn't have, like, it has way too many functionalities, to be honest, but it does lots of things. In this case, you can see here, it looks for scheduled tasks, right, which is what we want. And it will print the task name, the task path, and what is the class ID, which is what we want, the class for the com, right? But it will only look in the com for com classes. And then here, blah, blah, blah. This will test if the class is abusable or not. How? It will verify in the HKCR, which is the root registers, if the class exists there. And then it will look in the HKML LM local machine if the class is there. If it's there in the first one and in the second one, but it's not in the third one, right? HKCU populated. If it's populated, then if you modify it at your own risk, you might break something in the operating system. But if it does not, if there's nothing, if there's no com class there, that DLL there set it, then it will just say both are populated but not this one. So you can inject, right, and return true. And then we will use a class, a function. That's not here because I have the same project in more than one place. Yeah, man, it's hard to be me. Raise encoders, and then this is the one. It's the same, but it has one function more. So this, the same. As you can see, everything is the same. And this is the abusable task com to verify if the com. You just pass the class here, and it will verify. And then you have the actual abuse schedule task com, right? This will pass the class ID, the DLL path where you want to save the DLL, and the URL from which you want to download the DLL, right? So it will download from here, save here, and modify this class, right? It's pretty much the gist of it. And if you look in the main class, and this is an executable, not a DLL, right? This is what it's gonna do, right? So it will look for this class. It will save the DLL here with the name malicious. Yeah, man, badass. Detectable though. And then it will look for the DLL in the IP that, once again, I need to look up. Yeah, you would think that by now I would remember, right? But that's not how my mind works. She doesn't like me. My mind doesn't like me at all. So we come here, host it, and we will download something. Something.dll, right? So it will save as this name, but it will download here. And we save it. And hopefully it will work. Because if it doesn't work, doesn't care. It doesn't matter because I already presented my piece, right? So we just do the same now as a test and do system, reflection, assembly, load file. Oh, load file. Oh, actually, no. No, you don't need to do that because it's an executable, right? Encoders. You can just do like this. Down, and you can see it says it's not abusable. Why is that? Because it's already infected. God damn it! We have to create a new user to make it works. Because if you look at the class there, it will already have something in the register because it's already pointing to my malicious, which is, if you look at my folder here, user X malicious.dll. It's already there. Yeah, crazy stuff. Anyways, so now that we have it, let me just copy this somewhere. Yeah, I can, but I don't want to go into the trouble. That's why I'm gonna type lots of passwords. Let me just save it here. Come here. It's already. I can close everything now. Match user, yet another one. The password 1 2 3 4 5 6 7 8 9 and I don't know if the let's do it like this. And God damn it. Yes. That's it. Net local group. I'm gonna add as admin just because I'm gonna use this user now. Anyways, uh, local group administrators. Yet another one. Add. And now we just sign out. Oh man, thank God the password is easy. I would not remember the password now. I was already thinking, what was the password? So come here, grab this, go back there. Let me just place this here. I forgot about this. You were right, I should have cleaned the rest. Yeah, you can take my location, do whatever, just leave me alone. Man, you know what's the worst part? This is the worst part, man. It like by default it has the what's the name? Yeah, no, the effects in the user interface. And with VirtualBox on Linux, it just breaks. You can't do any. Oh, look at this. You can search something, it doesn't work. It just breaks. It's yeah. You're lucky you don't work with me because I complain all the time, man. Anyways, yeah, let's look for PowerShell here patiently. I don't even remember where PowerShell is. Oh, here, there. Down, flee. That was an error of the file system. Anyways, you can see now it's the register is abused, right? So now if we just log reboot, I can't reboot. Yeah, we do it the old good way. You see Windows, even in VM, you have to pull the plug, man. It's oh, it's reinitialize. I'm just gonna turn off and turn on. Okay. Let me just keep it here because once we log in there, we have to come back here and see if it worked. And if it didn't, yeah, it didn't work. Let's see if all right. So God, when I execute when in the red utils, I'm saving the malware into the user X user, but I'm not using that user anymore, right? So that's why it's not executing because it will execute with permissions of this user. And now is the challenge. Ah, yeah. Let me just modify the red utils. Oh, what's I open the project. I'm not gonna trust the shortcuts there because I don't know which one is it. This is the one. So you can see here I'm saving it into the user folder, which is the first user, the one that it's. So we have to save it in yet another one, right? We save it here. We build. We don't waste time looking for it. We do like this. PowerShell, copy, encoders. Go. Now it's real quick. Sorry for that. It's this one, right? Oh no, I don't have to do anything. Now I just have to go back to the other user to sign out here. And you have to reboot. So it's not just relogging because the class is already in memory. It's not gonna work. You have to actually reboot and look at this. Not funny, man. Seriously, it's crazy. Crazy, man. Yeah, it took a bit more time. Sorry for that. We managed to bypass in time, but for this part, I got a bit off the rails. Sorry for that. Didn't work. God damn it! I tested several times before. It didn't even download the malware, so it didn't work. Anyways, folks, that's all I could show. Yeah, and the next time when we are just having fun, like another day I can show you this working. But right now I had enough. And then it's like if you have any other questions, just remember things to remember when it's antivirus. Never touch the disk. Use HTTPS. Encrypt your payload. Hosts or you have to take care on where you're gonna how you're gonna deliver the payload to your malware, right? So it's basically a stager. Your malware is a stager, right? Stage one. In this case, you have to remember that this is kind of a stage one from five because it's the payload, it's the malware. It's first is the PowerShell that will download the DLL, that will download the shellcode, and the shellcode will execute the stager from the C2 that will download the rest of the code of the C2, and then it will work. So it's kind of five steps, right? So, but that's about what I had to show. If you have any other questions, if you want to bypass EDRs and everything as well, you have to read about unhooking API calls, static uh, pointers to the functions of the API, and you also have to bypass the ETW because what ETW will do is take the events and forward. The EDR generally has an agent in your machine, but it's not running your machine, right? It's running somewhere else, and what the agent will do is parse those events, log events generated by the ETW collector, whatever it's running there, and we'll send it to the EDR. The EDR will then do a post analysis and analyze the behavior. So this, like in this case, AV is clueless, but in EDR would see, oh, Notepad just started a shell. What the fuck, There's something wrong here, and will alert the blue team like right away. And it's not just that; it shows the context. It will show comments executed before the malicious part and after. So the blue team has all the context of what happened. So you have to really avoid that. And that's pretty much. Peace.